Welcome to all. This is the concluding part of analysis of singly reinforced and doubly reinforced rectangular section by limit state method. Further, what I am going to do, I will explain when I upload the classes. Practice, see, already for doubly reinforced section, many examples are over to find ultimate MR. Still, last time one practice question I given, where loading part is considered, but still important is ultimate MR part. Today also same thing. Main purpose is to practice thoroughly how to find ultimate MR for WN section where trial and error procedure is required. Directly you cannot find it. If anybody, some people, they get it directly by some splitting of steel area. It is wrong procedure. You have to perform trial and error. No other way than trial and error. Okay, start. Practice question 2. Remember, loading part I will explain. But ultimate MR part I wrote somewhere here. Now you enjoy. Now you have to enjoy it. Ultimate MR. So I have already written the trials here. See, 1, 2, 3. 2 trials. Actually, second trial, it is almost over. Third trial, starting only in the beginning, you get the answer. Okay, start. I read the question first. I dictate the question, copy it. Because here, you should understand the question correctly. A cantilever beam is of span 2.2 meter. It is loaded by a dead load of 16 kilonewton per meter, excluding self weight, and a live load of 10 kilonewton per meter. Okay. Now, cross section of beam is 230 millimeter by 700 millimeter. The beam is reinforced on tension side by 6 bars of 20 mm diameter in 2 rows of 3 bars each with a clear cover of 40 millimeter and clearance of 32 millimeter between the 2 rows. And on compression side by 3 bars of 16 mm diameter at a clear cover of 40 millimeter. Taking M20 concrete and torque steel of grade Fe415, check the safety of the beam. Full stop. Now, further continuation. First write, check the safety of the beam. Right, next paragraph. If unsafe, find how much live load is to be reduced. Whereas, if it is over safe or if it is safe, find how much more live load can be applied. Over. I will explain later. Second half I will tell later. Start now first. Remember, beam with the given loading, span 2.2, dead load of 16 including self weight, live load of 10, span 2.2 meter. Okay. To check the safety, already told, for safety, factored maximum BM should not exceed ultimate MR of the cross section. So, for the given loading, first find factored maximum BM. Remember, the given loadings are service load or working load. So, but this dead load of 16 is excluding self weight. Find first self weight. I will not explain how to find self weight now. Okay, 4.03. Now taking gamma F is 1.5 for dead load plus live load, factored UDL WU equal to 16 live load plus 16 dead load without self weight plus 4.03. This is the total dead load. This is live load given. Add those two, multiply by 1.5. You get 44.61 kilonewton per meter is a factored UDL for the given loading. Factored maximum BM. Remember, fixed cantilever, which will be at the fixed end, equal to formula is, suppose you take UDL as WU into L by 2. These all I can't explain here. If you got more knowledge, go to my playlist and search, go for SFDB MD course, where you can see everything. Okay. WU 44.61 in 2.2 in 2.2 by 2, 107.96 kilonewton meter. Means whatever load they are applying, service load, after you convert into factored load, the beam will have maximum BM of 107.96 kilonewton meter. Now I can tell, if the resisting capacity is more than this one, it is safe. Or if it is exactly equal to this one, it is marginally safe. But if the resisting capacity is less than this value, beam is unsafe. So now you can check the safety after finding ultimate MR of the cross section. Write the cross section, everything thoroughly explained so far. Now briefly, the box values are, you have to calculate, remember. The D, AST, ASC, D dash, this all you have to calculate. So therefore, everything over. Now see, I wrote the values here. What you have, first of all, I should not talk about this one now. It is already beyond the limit of explaining. How many times I explained, you go. Again remember, if you want to understand the loading part, today's class useful. If you want to understand correctly ultimate MR calculation, you have studied all the question, including procedure. Okay, finally, ultimate MR will come 358.98 kN meter. Okay, now, last step. I will conclude the last step here. I will not, like usual, rub the board and prepare second round. Here only I will do it. Just 1 minute. Here only. Okay, this is loading. This I will remove now. Okay, I will make a note here. Okay, I'll write here. See, now. Therefore, continue. Factored maximum BM, which is how much? One for BM for right here, for given loading. For given loading, they already told the load. Given loading, that is 107.96 kilonewton meter is less than ultimate moment of resistance of cross section. It is here only, right? 358.98 kilonewton meter, right? Therefore, safe. Now, if someone will ask a comment with me, I will tell. See, bending moment 107. They provided the beam cross section with reinforcement to resist a bending moment of 358. Means the person who provided cross section has liberally given. I will tell, for this loading, that much cross section is not required. By judgment I can tell. But anyway, it is a given question. Actually, I only gave it. Deliberately I have given a cross section which has got over strength. Therefore, you can tell what they want. Check the safety. This beam is, for the present given loading, the beam is safe. If they want only, by chance, your factored BM comes more than ultimate MR, write unsafe or not safe. So if they want only to check the safety, your question is over here. But here, continuation required. So therefore, I will do one thing now. This I will remove. See, for continuation, this I will remove. This all I will remove. I will continue here now. Usually I clean the board neatly, then start. But I thought today, why waste time? Little more rubbing required. Okay, done. In time I am not getting that. Okay. Now see, you make a note here. If they want only to check the safety, what you do? Just write the comment, safe or unsafe, and stop there. Right here. But, second part, they told, what they told? They asked us, second part, to find how much additional live load can be applied if safe. Now, second part is, see, if safe, they are asking, if safe, then find how much, yes, this is, how much additional live load can be applied, or if unsafe or not safe, how much live load is to be reduced. That means the dead load they cannot change. Remember, the dead load will remain. Their only option is change the live load. Okay, what to do? Do one thing, both common. Let WU be factored UDL maximum factored UDL beam can support. This will tell you the answer. See, for both of them, safe means how much extra UDL you can apply live load. Unsafe means how much live load to be reduced. For both of them, common calculation. See here now. Support. Now, then factored maximum bending moment equal to, see, don't take WU into L 2.2 into 2.2 by 2 equal to, I should 2.2 square divided by 2. 2.42 times WU, actually in kilonewton per meter. 2.42 WU kilonewton meter hogging is the bending moment. Now we have to find the maximum possible. I told you, check the safety means compare. If you are asked to find the maximum load possible or unknown is there, equate. What you do? Equate factored maximum bending moment to ultimate MR of cross section. Briefly I am writing 2.42 W equal to MR 358.98. So you get WU. Therefore you get factor you get what? WU you will get equal to 358.98 divided by 2.42. 148.34 kilonewton per meter. This is all inclusive. All inclusive factored. You can write here. All inclusive. All inclusive. Now, this is the factored load. Therefore, what? Maximum permissible service load. Right, fully. Maximum permissible service load in the form of UDL equal to 148.34 divided by 1.5. This all I told earlier. This, see, one class I had taken fully for factor of safety only. Go through it. 98.89 kilonewton per meter. This is once again all inclusive. That is dead load plus live load. Now, see, dead load plus self weight is equal to how much? Dead load is 16. I removed the self weight here. I have to calculate once again. 0.23 into 0.7 into 25. 4.03 is 4.03. This they cannot, 16%. 20.03 kilonewton per meter dead load is there. Including a dead load plus live load, beam can support 98.89. Therefore, maximum live load beam can support equal to 98.89 is all inclusive. Subtract already existing dead load of 20.03. 98.89 minus 20.03 equal to 78.86 kilonewton per meter. But the question is, how much additional live load we can apply? So, see now, already applied live load equal to 10 kN per meter. Therefore, additional live load permitted or anything. Okay, additional live load beam maximum additional live load beam can support is equal to, I write here now, 78.86 minus how much it is? 10. 10 Allah? Yes, 10. 10 equal to 68.86 kilonewton per meter. Over. Now, 1 minute. Make a note. Suppose the beam is found to be unsafe. Then, this service load, including self-weight, you will get what? 16 plus self-weight, 20. 30 working load is what? 30.03. You will get less than 30.03. So, then permissible live load will come not 78, it may come around 6, 7, suppose say 7 kilonewton per meter. So 10 is not permitted. You have from 10 subtract 7. Very simple. How if you are already applied load is 10, but beam can live load, but capacity of the beam is up to 98.89. No, sorry, not 98.9. That is yes, 98. No, live load is not 98.89, 78.86. So another 68.86 is permitted. Okay, over now. I am concluding now. Now I will start uploading new part. One of them is design oriented class. How to find the area of steel required, tension steel required for singly reinforced section, and how to find area of tension steel and compression steel required for doubly reinforced section by limit state method. One more I am uploading. Design of shear reinforcement by limit state method. Then last uploading, analysis of T section, ultimate MR. There are two cases are there. Neutral axis in the flange or web. If in the web, there are two sub cases are there. That all I will tell you at that time. Okay. Now, analysis part is over. Thoroughly go through every class conducted so far. Starting from the first class working test method. Recent, you can see there. In the playlist you can see working test and limit state. Working test, even though practically not used, understanding purpose very important. Those who want knowledge, if any doubt comes here, don't blame on me. It is your problem. You have not studied properly. You go through all the classes and then come to this class. Suddenly you can't come and tell, nothing is clear. Somebody may tell, what is going on? Nothing going on. I will tell you, came directly here. How you can come directly here? In the order you have to come. Okay, thank you. We will meet in the next class.